Look, intern, this is not going to be an easy day like other jobs. I see a lot of interns, they come in here, they don't know Git, they don't know GitHub, and they think that they can keep a job at next work.
Oh, understood. Yes, sir. Yes, sir.
Well, we're going to go through the basics of Git and GitHub. We're going to clone a repo. We're going to set up branches. We're going to create a pull request. We're going to merge. We're going to deal with conflicts. We're going to ship an actual feature. And if you can't do this test by the end of today, you will not have a job at next work. Mark my words.
First on the list, what's the difference between Git and GitHub? Oh, boss, I love this question. And I actually think about it like this. Like, let's say I'm working on a project on my laptop and I go ahead and create a folder. In Git terms, this right here, this folder is called a repo. And what Git allows me to do is track the changes that I've made to the files in this repo over time. And this is all done locally. Now on the right here, you've got GitHub. And what GitHub allows me to do is take that same repo and instead store it in the cloud. Now, instead of everyone just passing around random copies, all these people right here, all these beautiful people, they can work on the same project with me in GitHub. This is how real teams work.
Okay, not bad. And what if GitHub disappears tomorrow?
The cool thing is that Git will still work. The full history lives locally on my machine right here. On my laptop, I have all of these project files, and I also have this .git file, which is going to track my history of all the changes. Now, GitHub, it is just another copy of the exact same repo that I have right here. So if this remote copy vanished, I still have my project files right here in my local machine.
All right, so Git is the engine on your laptop and GitHub is just a cloud copy with extra features. So why do we really need GitHub?
Because it adds a few important things around that repo, like backup, for instance. So if I lose my laptop, then it does not mean that we actually lose the code. Or collaboration. We'll talk about PRs, reviews, branches, but essentially we can collaborate with other people around the world and work on the same project. Or visibility. Of course, there's issues, there's docs, there's a project home, and this creates a one central place where everyone can see all the changes that are being made.
Where do other developers in our team fit into this? How would this work practically?
So each developer has their own local GitHub repo, like developer A here and developer B. And they all sync with the same GitHub repo. So everyone works locally on their own copy, and then they push and they pull all the shared changes on GitHub so that we stay in sync as a team.
And most of the time, are you working directly with GitHub?
No, so most of the time I'm actually just working locally and I only sync changes when I need to. So I kind of think of it like two layers. Our local Git version here, where I edit and I record the history of the changes that I make. And then the GitHub copy is where the team exchanges work. This is typically the more polished version of the app.
All right, not bad. So now we need to set up Git on your machine so it actually shows up with your name in the history. Walk through the setup of Git.
All right, finally we can get to the real thing, which is first, what I need to do is open up something like Cursor or VS Code or your terminal. You just essentially want to have access to a terminal. It doesn't matter which one you use. They're all just different doors to the same place, which is your machine. And it's where we need to install Git. For the sake of this, I'm just going to use Cursor.
Yeah, exactly. We use Cursor as well in our team, but I've seen some interns using Google Anti-Gravity, but who knows? Anyway, keep going.
So since we're in Cursor, I'm just going to go ahead and open a project, and I'm going to create a new folder in here called, I don't know, day one. Can be whatever we want, but remember, this project is our repo. I'm then going to go to the top of my screen. I'm going to open up a terminal here, and what I'm going to check is Git version. I essentially want to check if I have Git installed on my machine. Now, since I do, I see something like this. I have a Git version number here, but if I don't, I want to go to the Git website, which, I don't know, if this was a video, I'd say this website would be like in the description of the video or something. But I want to go to the Git website and I would want to download Git. So all I would do is download from my operating system. And once that's done, if I go back here and I type in Git version again, I should see something like this.
Nice, but who is the laptop actually sending your commits as?
Yes, boss, that is spot on. Like next step, I need to tell Git who I actually am. And Git keeps this information in a config file on my machine. And the reason it does this is so when I save changes or commit things, it knows who it's coming from. So the main one that I care about right now is the global config file. And this is the settings that apply to me across all repos on this laptop. So in the terminal, I'm actually going to go ahead and type in git config -- and then I'm going to type global user.name. I'm going to add a space and then go Maximus, which is my name. Obviously, if you're on your first day at the job, you wouldn't copy mine, but I can go ahead and press enter. Now I want to do the same thing again. So I could actually just press the up arrow on my keyboard and then just go back a little bit. And I'm going to go user.email and now type in my email. So mine is maximus@nextwork.org, and I'm going to hit enter.
And that email should be the same that you use for GitHub.
Exactly. I want to use the same email that we will use when we create our GitHub account. So when we push, GitHub can recognize those commits as our own and then tie them to our account. So to quickly just double check that we've done things right, I'm just going to go git config -- global, spell global right, and then go -- list. Now here you can see my user email and my name, and if you see something like this, then you know you are on the right track. If that is correct, now we have an editor with a terminal that we're comfortable in. We have Git installed and it's visible on our terminal, and Git now knows our name and our email and will tag every commit or save that we do with that identity. So now my machine is ready to be pointed at a real Git project.
All right, nice intern, you made it past step 1, but now we need to actually create a GitHub account for you.
I do not have a GitHub account, so I'd actually want to go to github.com and then we can go ahead and sign up for GitHub. Now in here, it's going to ask us to pick an email and a username. Just make the email the same as what you typed in for your Git config. So can be, for me, it's maximus@nextwork.org. And for the username, you can pick anything, but you just want to make sure that it's something that you are okay with seeing on repos. So your name will actually pop up on the repos that you build. So for me, I'm just going to go, so I can create my account as I normally would, and GitHub's going to ask for some verification. Once we're all done with that, we're going to have our own GitHub profile, which is pretty sick. I mean, I chose the name Minimus7, but I can now have my own repositories in here. And when I push commits from this laptop, GitHub can link them to this account.
Look, this is good. You're making progress, but you are not touching our repo right now. You need to make a fork and a clone.
Yeah, that's right, boss. And what we're going to do is actually go to this project guide here, which is at learn.nextwork.org. And if you are watching a video about this, it would also be in the description. And what we're going to do is we're going to take this link here and we're going to create a new tab and paste it in. Now this repo, these files, is the official Nextsound repo, so the company that we're working for right now. And it is public right now, which is not normal for a company's repo, but it's set up for the purpose of our demo day today. Now the thing is that even though it's public, anyone can read it and suggest changes, but these 3 contributors right here, they are the ones who control what actually lands in this live version. So for today, we are not testing Git on that real repo or bothering the people here, these contributors. We want our own sandbox environment where we can break things safely.
Good. The last intern that I hired, he was useless. He broke our entire repository, so you need to work in your own one.
Now what we're going to do is something called forking. So this is a copy on GitHub of the same project, the same repo, from that company repo into our account. So if I go back to this here, we can actually go up to where it says fork right here and click on it. And you'll see now you are the owner. It's going to default to your account here, and you can choose the repository name, you can add a description, but I'm just going to go ahead and create a fork. So right now what we did is we took that Nextsound repo from the company. We then forked it on GitHub. So we created a copy that's our version on GitHub. And now we need to clone it. So cloning is a copy from our fork down to our machine. So what I can do here is go to my code and I can click this right here and go clone using web URL. Now I can go back to my terminal here and type in git clone and then paste in that URL. So you see Minimus7 is my username, so I know that it's mine.
All right, intern, slow down. Talk me through what actually just happened.
So right now in my terminal, we're still in that day 1 folder, this one right here that we created earlier. Now we ran git clone from there, which means Git took the Nextsound repo from my fork on GitHub and created a new folder inside day 1. So if we look inside day 1, we'll see Nextsounds in here, and we have all of these files that are included right here. So visually, day 1 is just my workspace for this tutorial, and inside that is the actual project repo that we cloned. So now there's actually only 3 commands that we really care about right now, and the first of which is pwd, and this means print working directory. and it prints the full path for where I am. So right now you can see I'm in users, Maximus Suarez, which is my account name, desktop, and day one. So we are in that day one folder, but we're not within next sound. So from here, instead of just clicking around the file explorer, we could actually just run ls, which lists the contents of the current folder. So then we can see that next sound is the other folder within day one. So finally, we could actually run cd next sound, and this is change directory. And you'll see now next sound is actually the directory that we're in. So if we run ls again, you'll notice all of these files, which was exactly what we saw over here. So if I run print working directory again, you'll see we're now in the next sound file. So from here on, every command for this project runs inside the next sound folder, because this is the actual repo that we want. All right, this is good. The repo lives in your laptop and the terminal is actually pointing at the right folder. So now show me that you can actually run the app. Yeah, exactly. So right now we cloned our project and that gave us a local copy, but our app actually needs dependencies installed on our machine. And when I say dependencies, I mean other people's code that the app is actually built on top of. So things like React or the build tools or UI libraries or helper libraries, code that is not in the repo, but that our code imports. And we have to actually be able to install these dependencies. So the way that I'll do this is I'll go npm install and hit npm install there in the terminal. And sometimes you're going to see an error like this. So you can just go npm audit fix and it should run. Now npm just stands for node packet manager. And it essentially just reads this package JSON file. And this package JSON file, if I just close this up, this has all of the required packages that we need to download. And when it downloads them, it puts it into this folder on our machine called node modules. So when this project finishes, the project still has the same core files, but now there's a big node modules folder here that only exists locally. Now later on, we'll talk about how Git actually treats this folder, but for now we just need it so that our app can actually run. So now with the dependencies installed, I can run the app in a development environment. So what I can do here is just expand this terminal out a little bit, and I'm gonna type in the command npm run dev. Now this is using something called vite under the hood and print something out like this, localhost 5173. Now essentially this just means that the app is running on my machine and it's listening on port 5173. So localhost is just a special name that points to our own computer. So if I just hold command and click and open this up, you'll see here that our next sound app is actually running. So this is the cloned repo that we took from the next sound repository. And here it's a Spotify inspired app where you can play songs, and I mean there's Taylor Swift over here. You can queue up different songs, you can search for things, but this is the app that we are working with today. And from now on, when I make any changes in the code base, we can flick back and forth between our local host and our code base to see the changes that we made in real time. Intern, you're not doing bad. You've cloned the repo, you've installed the dependencies, but you need to actually start using Git now. I want to see how you'd save your work. I want to see what you would actually choose to keep, how you'd record it. Go. All right, I'll explain how Git thinks about our work, and then I'll do it on the actual next sound repo so that we can see the changes for real. How does that sound? So Git actually thinks about your work in 3 places. Now, the first of which is your working folder. Now, this is just your project folder on your laptop, on your disk. And these are the files that we're actively editing in Cursor or VS Code or whichever IDE you have open. Now, the second place is the staging area, and this is Git's short list of the changes that we have picked up for the next save. Now, when you say, I want this in my next commit, you are talking about the staging area here, which is what we're in. And the third place is the commit history. So this is the list of the snapshots that Git has already locked in. Each commit is just one of those snapshots. So the working folder is the messy desk. The staging area is the neat stack that you are about to file. And then the commit history is the filing cabinet. All right, show me this in your code base. So I'm inside the terminal now, and I'm just gonna spin up a new terminal, which I can do by clicking this little plus button. And you can see I'm still in the day one folder. So I actually wanna go CD into next sound as we did before. and you can see that I'm now in the Nextsound folder. Now I've already run npm install earlier, so the dependency files have changed. We know that, right? These node modules, package JSON, all of that has been added in. But for this chapter, I'll add in one more clear change so we can see it together. So I'm gonna go ahead and open up this README file here, and let's add a sentence at the bottom. I'm just gonna say, hi, you are cool. Now after that's done, I'm just gonna save this, and then in the terminal, I'm gonna write git status. So now git status is actually showing two files here that have changed, which we can see by this modified symbol right here. So the readme file is the change that we just made, and then the package lock JSON file. So that's coming from the npm install that we did before. The package lock JSON file is the generated lock file that pins exact versions. So seeing that both of these are modified after installing or changing dependencies is normal. So right now, if we take a look at those three areas, the changes that we made only exist in this working folder right here. It's not in staging yet and it hasn't been committed. So we need to do something about that. Don't just tell me this, show me what you've actually changed. All right, man, all right. We'll make those changes. So all we need to see right here to see the exact differences of what we've changed is we can type in git diff, and then we can also type in readme.md. So now you can see in here the changes that we've made are these pluses right here. So we've added a space at the bottom, which we've added just here. And then we also added this hi, you are cool. So we can see the changes that we've made. Likewise, if I just delete this line right here, save that, and then I run this command again, so I can just press up arrow on my keyboard, you're gonna see that if we delete something, there's a red line here with a minus symbol, and then we've deleted something from our README file. But again, I haven't staged anything yet, and we want to try and move this along the diagram now. I want you to treat this like actual work. Pick what you want to save, and then move that into the staging environment, the middle box. So first I'll just stage the README change so that you can see the difference between staged and unstaged changes. So what I'm going to do is go git add, and then README. So we want to add those changes, so we can do that. And now if I go git status, you'll see that my changes here, which is changes to be committed, the README file is now included, and changes not staged for commit is the package lock JSON. So the README file is in the staging area, and the package lock JSON is in the working area. Now I also want to stage the package lock JSON, so what I can do is just go git add space and then dot, and that is going to actually commit all the changes that we've made. So now if I go git status, you'll see that both the README and the package lock JSON files are in the staging area now. All right, so your staging area is full now, but show me how you would actually commit this to history. So right now the README and the package lock JSON in this staging area right now, but we need to actually commit these changes into our commit history. So we need to put these files into the filing cabinet, and we need to do that with another git command. So with all three files staged, I can run a command like this, git commit -m, and the -m just means message, and then you're gonna have an apostrophe, and now you can actually type in your message. So typically the format to do this with is chore. So in this case, this is a chore that we've done. We're gonna update dependencies and tutorial readme. So here you can see two files are changed, 12 insertions, 10 deletions, and now we can run git status again, and you will find that there is nothing to commit anymore. So the changes to the README and the package lock JSON file have all been recorded as one in the commit history, and the working folder is now clean again. Our staging area is empty. Look, a lot of people say commit, but can you actually describe what a commit is? Yeah, it's a really good question. And for us, a commit is a snapshot of everything that was in the staging area at that moment, stored in the commit history. And we do that with that git commit command. Actually, this is a good part to stop. Most people mess up these commit messages. So talk me through how you would think about them. Now, something that a lot of people get wrong here is that we want a commit history, so the thing where we said chore and then the message, to actually be readable just by skimming through it. So we don't want our commits to say like update or final. That red box here, this is bad commit history. It's really hard to tell what actually went on there. However, the green box here, this is good commit history. So things like feat for a new feature, or fix for a fix, or tweak, or copy, or docs are good practice when you're writing a commit message. because you want to write a git commit message like git commit -m, then your message being, let's say you had a fix and the fix was, I don't know, let's say the play button wasn't working. This is very clear as to what your commit message is, what your commit is actually done. So anyone who's reading this will be able to get it really quickly. Exactly, intern. This is good because if I'm trying to look for a commit where someone broke like the play button or something, I can just easily scan through the logs. Show me the history from that terminal. Exactly, and the same commit that I just made, I could actually just type in git log --one line. So here what we are seeing is each line is one commit, and the short string on the left, so these numbers right here, this is the abbreviated commit ID, and the text on the right is the commit message that we or other people wrote. So in this case, I can see this is the commit message that we just wrote, but these ones here are the commit messages that the previous contributors wrote. So from this, I can see that we were the last commit, and git log isn't changing anything. It's just showing me the checkpoints that are already in this filing cabinet with the newest one at the top. All right, you know how to save changes now, that is clear, but I want you to show me how you would not save things like your node modules or your API keys. Oh, this is such a good point. In our project files right here, in the Next Sound app that we're running, we have some files like source or server or public, and these are files that we want to live in the repo. Now, the simple idea is that we have some local only files. These are things like the node modules, the .envs, that we don't want in our Git repo. And then we have some shared project files that we do. And the way that we control this is by using a gitignore file. And this essentially tracks the first group, but ignores the second. And let's go through some of the examples, like our .env file. This is where we ignore any real environment files that hold secrets. So like our API keys, things that we don't want to show other people. We also have node modules, which we installed earlier when we ran npm install. Now, the reason we don't want something like node modules to live in our repo is when we run something like npm install, this node modules file is going to download thousands of files like we saw, right? And you should never commit this. It should only stay local. And the reason we don't do this is because it makes the repo really huge and slow to change. And also, this node modules file can drift out of sync with our package JSON. So remember, we had those dependencies, and those dependencies have different versions and packages that they can run. So different per platforms. So we don't want that file set to be fixed in place. We actually want someone to be able to run npm install and update the latest versions of these packages and dependencies. So that's why we want something like our node modules in our gitignore file. So if I go to my terminal right now and I just spin up a new terminal, cd into next sound, and I can run git status, you'll notice that in here, there is no node modules, there is no .env file, there's no .ds store, because they're listed in our gitignore. Now, if gitignore was new, we would write something like git add .gitignore, and we would run this and we would commit it as we normally would before. But from then on, it stays local, so the rules are shared, but the junk, they hide and stay local. Look, intern, it's been good so far. You've shown me you can have clean commits and that you also know how to use gitignore. But most people don't know how to use branches properly. I would love to show you some branches. This is one of my favorite parts. So far, we have done everything in this branch called main. So if I look at our code base right here, you can see at the bottom, we are in this branch called main. You can see it right there. Now, main is the stable line. This is this right here. It is the stable line that the entire team should be able to trust, and is usually the version that is in production. Now, what a branch is just another line of history that splits off from an existing commit. So let's say we wanted to make a header feature in our app. So right now we're looking at our localhost app, and one thing I don't like is I don't like how there's no header at the top. Once we scroll down, the header pops in, but I would rather a header be there the entire time. Now, instead of just making all of these changes on our main branch, I actually want to create a new branch called feature header 1. This is the same project. It's the same files as what it was at main. So we have main A, main B, main C here. Now, these are all commits like we made before. Now, let's say at main B, I made a commit and I thought, oh, well, actually, I don't like the header. I want to make a new branch. I want to make some changes. Now, I can then make this feature header branch right here. And this branch is the same project, the same files. It is just a separate timeline of commits where we can work safely without affecting main, without affecting what's in production. When I'm happy with those changes and I think everything is right, I can then merge it back into the main branch, but only when I'm happy with those changes. Good explanation. Now show me that in the repo. So now that I'm back in this next sound repo here, I'm just going to go back to here and I'm going to go git branch. Now right now it probably shows this dash and main, and that's because we only have one branch, which is main. So the little asterisk is just showing us which branch we're on, but I want to actually create a new branch for that small header change that we want to make. So I can go git switch -c, and then in this case ours is going to be feature header change. So now you can see we've switched to a new branch called feature header change, and you can also see that at the bottom left of your IDE. In this case, git switch is just moving between branches, and C in the git switch command is just creating a new branch and then switching to it automatically. So now if I run git branch, oh my gosh. So now if I run git branch, you can see that I am now in the feature header change branch. If I make any changes, they will not affect main. They will only stay on my feature header change branch until I have merged those changes back in, which we will do in a little bit. So now I'm just going to go into our app here, and I'm going to take a screenshot of our header here. I'm actually going to go into the cursor chat window. If you haven't used cursor, don't worry, we can cover that in a later onboarding day because this is an onboarding, not a video. So I can go into the top right hand corner and I'm going to say something like, I want you to make it so that our header is permanently fixed in the black color at the top of the screen. So now cursor is going to go ahead and make the changes to our code base. And keep in mind that this is only happening in our feature header change branch. So now you can see that cursor has made some changes, and we can go back to our local host here and you can see that it has done exactly what we wanted. So it's made the header black. So that is a good thing. So now, like before, we could go git status, and you're going to notice that the files that were changed here are the source files and then our header files in the index.tsx file. And that is exactly what cursor is saying on the right hand side here. So we want to add these changes. So we can go git add, and in this case we can just go dot to add all. And we also want to commit these changes. So in this case we want to go git commit -m, and our message here can be tweak made header black. And then we've committed that. So now if I run git status, you'll find that there is nothing to commit. So our working tree is now clean. And again, if we look at git log -1 line, we can see our latest commit here at the top. But you can see that we've committed to our branch here. We haven't committed to main. So main is not going to see these changes. All right. Now merge it back in without breaking main. Now what you'll find here is if I switch back to main here, the header on our app will still be the old version because our main doesn't have these commits yet. So if I go git status over here, what I can do is actually go ahead and merge our branch into main. So I can go git merge feature header copy or change, which is the name of our branch. Now I just did this before, but it didn't record. So mine already says it's already up to date. But yours should look something like this. Can you tell me what this means right here? Ahead of origin main by 3 commits. Explain that. Now the reason you're seeing this right here, your branch is ahead of origin main by 3 commits, is because when I first cloned this repo, Git set up a connection between my local main and the main branch on GitHub, which is always called origin main. Sometimes it may be called origin master. Since I've made a few commits locally, including the header change, but I have not pushed anything yet to GitHub, my local main now has 3 more commits than the origin main on GitHub. So that message is just telling me that your laptop has work that GitHub doesn't yet have. So you can run git push to upload it. For this part of the day, we've just focused on local branches and merges. Next, we can talk about how to change that to GitHub maybe. For now though, the important last line of nothing to commit, working tree is clean, tells me that the merge has worked. So now on localhost, I should be able to see my header, which is correct. This is exactly what we want. And the last thing we want to do is go ahead and delete this branch. So we'll type in git branch -d, and our branch is called feature header -change. So there we go. Our branch is deleted. So now if I go git branch, you will see we only have main. All right, that's the basic flow. Good job. Let me make this practical so it's not just a demo. I think there's times when it's fine to commit straight to main and times when you should definitely be using a branch. So if it's a tiny personal project and I'm the only person touching it and it's not deployed anywhere important, then yeah, sure, committing to main is usually fine. The flow is quite simple. I make a change, I run git add dot, then I run git commit, and I write a clear message. And if you want it on GitHub, I push main up to origin main. But for a shared repo or anything that is deployed or anything with a non-trivial feature or a bug fix, I should be using a branch. That is definitely best practice. So this is going to be the workflow that we're going to look at now. All right, so far you've shown me that you can create a branch from a clean main. You've done some real work on that branch. You've merged it back in safely. But now I want you to show me how this actually leaves your laptop and hits GitHub. How do other people see this? Yeah, boss, you're 100% right. So up to now, everything that we have done has been local. It's been on our laptop here. But to share it, Git actually lets us connect to a remote repository. And in our case, this was that nextsound repo that we forked from GitHub earlier. Now, if we want to push our local changes to our GitHub repo, we got to push it. And if we want to pull some changes from our GitHub repo, maybe other people have made, we want to pull it. I can actually go back to the terminal here and I can type in git remote-v. And this is going to print something like this out. And essentially what this is saying is origin is just the nickname that Git gave to the GitHub repo that I cloned it from. And the URL is where Git will send the fetch code. So when I say I'm going to push to origin, I mean I'm going to send my commits to my own nextsound repo on GitHub, not the original Nextwork one. All right, so we know from before that if we run git status, our branch is 3 commits ahead of origin main. So in order to send these commits up to GitHub, all we're going to do is go git push -u origin main. Git push is sending those commits. Origin is equal to the remote, so in our case it's GitHub and that nextsound repo that we forked. Main is the update, so the main branch there. We know it's called origin main. And then lastly, -u is set upstream, which means remember that local main tracks to origin main. And we only need to do this once when we run it first, and then we can just run git push from there. So now if we go into GitHub here and I open up the repo, now we can actually see that commits have been made. So we got our tweak commit here, which is make header black. We also have our chores, which we update our dependencies, and then also the tutorial readme. Now we've done git push, so obviously we got to do git pull, but we need to talk about git pull. And in this case, git pull is the opposite direction. So let's say, imagine I push today, and tomorrow I make a small change directly on GitHub, or I'm working with a teammate on the same repo. It's probably a more likely scenario. Now GitHub's main moves ahead of my local main. So they've made changes. So I need to then pull this. Git may say something on your local, like your branch is behind origin main by 1 commit, and it can be fast forwarded by using git pull, similar to what we saw before. This is basically saying that GitHub, we just run git pull. So let's say I'm in the code base, I go to the README, and I want to make a change to the code. I could go ahead and say, hi, you're cool, and I love you, exclamation mark. Now, at the top here, I could then commit these changes in GitHub itself, and GitHub actually has Copilot in here, so it's gonna go directly and create these changes. And instead of creating a new branch, I'm just gonna directly commit it to the main branch. So I can go commit changes. So in order to visualize the changes that we made in the GitHub UI, so on the origin main branch, you can see that if we run git status over here, it's gonna say that our branch is up to date. And this is because git status is only checking for things on our local machine. So what we actually wanna do is go ahead and run git pull. And what this is gonna do is 2 things. Now, firstly, you're going to see that 1 file was changed and there was 2 insertions, 1 deletion, and that's going to be our changes where we said, I love you. But by default, git pull does these 2 things. So number 1 is git fetch. So that's going to download the new commits from the remote. So that's origin main. And then git merge, which combines them into my local branch. So how often are you pushing? Every commit or once a week, twice a week? How often? I mean, that is a great question. So whenever you're doing a solo project, you can commit whenever you like. You can push whenever you feel like a backup, but for a shared or deployed repo, that's a bit different. You're gonna commit in small checkpoints, so you don't wanna build 10 different features at once. You wanna build each feature out by themselves. break things up into logical workflows. For a rule of thumb, commit as you go and push when another human could reasonably review or use these changes.
Good, as long as you're not pushing massive PRs. I hate that. I hate that so much. Don't sit on like a week's worth of unpushed work. Right, so you know what branches are now, but next we need to look at pull requests, and I was going to let you do this yourself, but I actually think it's better if I handle this one. So previously you learned about what a branch is, how to work with a branch instead of just touching main directly. Now I want to show you how that branch actually gets into main. So I'm going to show you a real example. So this right here, this is our live marketing website. I built this from the ground up, blood, sweat, and tears. Now over here, you can see on our beautiful marketing website, there is roadmaps that you can look at. There's things that you can go into like AI, machine learning. There's a beginner's challenge, DevSecOps, cloud engineer. The website is beautiful. There's a lot of projects you can do if you want to get into these topics. That is not what we're looking at. We're looking at this right here, trusted by 150,000 learners worldwide. Now this, I created it about a month and a half ago. Man, we're at 180,000 learners. So we got to change this in our code base. So let's look at this as an example. So if we're looking at this diagram right here, we got main. So that is our main code base. That's the Nextwork marketing website, which we're going to look at right now. Then we want to create a branch, and we're going to update our leaders count. So we're just going to call it feature update leaders count. From there, we're going to create a pull request, and a pull request is how that work that we've done in that branch asks for permission to then later rejoin main. So when you open a PR, you're asking the other people in your team. So if I'm working with other people in the Nextwork team or other people in the world, I'm saying compare this branch to main, and these are the exact lines of codes that I change. If it looks good, merge it. Now a PR is going to have a title and description. It's going to have code diffs. It's going to have some comments and a review history, and then a merge button. And remember that pushing a branch does not change main. Main only changes when a PR is merged. Keep that in mind while we go through this example. Now I'm going to go to cursor. I'm going to open up a new window, and I'm going to select Nextwork Marketing. So this is the code base for the marketing website right here. So I could run pm run dev, and I'm just going to spin up a local host right here. So you can see our local host is running. This is exactly what we're dealing with. I'm going to create a new terminal, and you can see at the bottom left-hand side, we're in main. So what I'm going to do first is just run git pull just to make sure that there is no changes. And you can see that everything is up to date in this main branch right here. And we want to create a new branch here, right? So we can go git switch -c, and we want to call this branch, let's call it feature update learners count. So we're in a new branch. You can see that in the bottom left-hand side here. And now I could actually just use AI to say, where in my code base does it say 150,000 plus learners worldwide? Obviously I could get cursor to change it if I wanted to, but I just want to show you how to do this. So I could go, okay, I can see it is line 47 in this index.astro file. And you can see right here, there it is, 150,000 learners. I'm going to change this to 180,000 and save. Now, if I run git status right now, you'll see that there is some changes, and it's only changes to this one file. So I know I can just run git add all. And then we need to commit our changes. So I'm going to go ahead and commit those changes. So -m, and it's just a copy change. And we're going to update learners count to 180K. So now if I run git status, you'll see that my changes have been committed, which is great, to GitHub. So I can go git push -u origin, and then the branch name, which is feature -update -learners, and then -count. So now I have pushed my changes to GitHub. So now if I just click this link right here, it's going to open up a new tab in GitHub. And you can see right now I am in a private repo. It is Nextwork Marketing, and you can see that there is a pull request that has been opened. Well, we're about to open it. So in here I can say minor change, where we have updated the text on the home page from 150 to 180,000 learners. Now in here, I could assign reviewers, I could assign other people to check these changes. But in this case, I'm just going to assign myself because honestly, it's quite a small change and I know exactly what I've done. And we can go ahead and click create pull request.
Now right here, before we actually do anything, before we merge in this PI, I just want to show you the different states that are currently occurring. This is obviously not the live production version, but we can see the change has been updated, 180,000 learners worldwide. But if I go to nextwork.org, the live website, you can see that it is still saying 150,000 learners worldwide. And this is because a created PR doesn't mean that it's merged in yet. Those changes are not on main. Now let's say I did assign someone to review my PR and they looked into the files that actually changed. Now they could go in, they could be like, oh, big problem here. It's actually 190,000. They could then say 190,000 plus, and they could send that comment to me. Now all I would need to do is go back to the code base here and I would make that change. So I could go 190,000, I could then add those changes, commit those changes, but I don't need to create a new PR. It sends the new commit to the same branch on GitHub, and the existing PR automatically updates to show the new differences. In this case, I don't want to make any changes because it actually was 180,000, so I'm just gonna leave it how it was. I have to add in a GIF that is engineering best practices, and then I can go ahead and squash and merge all these changes. So in here, I can confirm, squash and merge, and I can make this change. So now you can see that it is officially merged in here. You'll see that I also have a setting on GitHub that automatically deletes the branches after they have been merged. And this is just best practice to keep all of your branches clean. So now if I go to the actual website, nextwork.org, you can see that the change has been updated. It is super fast. We're deploying on Vercel, so things are very quick. So we want to go back to the code base. We want to switch to git switch main. We want to git pull origin main, and we want to make sure that the changes, so one file changed, has now been reflected in our main. Now intern, that was simple because we didn't fork the repo. Now because we cloned your fork on the nextsound repo, there is going to be some complications here. So in our code base, let's go to nextsound, and I'm gonna run our dev server. So npm run dev, open up this localhost, and I'm just gonna make a minor change in the header here. I actually want this search right here. I want to take out that command K. I don't want to use keyboard shortcuts. I actually like keyboard shortcuts, but I just want to remove it. So I'm going to take a screenshot of this. I'm going to go into cursor right here. I'm going to paste in my screenshot and say, I want you to remove the command K shortcut in the command window. Oh, and before I do this, I'm actually going to spin up a new terminal, cd into nextsound, and I'm going to create a new branch. I want to run this command git remote -v. We're going to see something like this: origin and upstream. Now let me translate this into normal English. The thing is, Git does not know about forks or GitHub accounts. So this is what it looked like originally. This was the original repo that we cloned and forked, and now it looks like minimus7 nextsound. So I own that. This is owned by someone else, and a remote is just a nickname for a Git URL. Now, by convention, the origin is the main remote or URL for this local clone. So this right here. In a fork setup, the origin usually points to our fork, which is in this case minimus7, which matches minimus7. Upstream, however, is usually set to the original repo, which in this case came from our fork. And we can see here that upstream points to new owner, new repo, which is basically just a placeholder or some other repo. It is not the real nextsound repo. So for this part, we can ignore that. Now in an ideal setup, we would want to git pull upstream main to pull the latest official code from nextsound repo. But for this command K example, we only need really one thing. Origin is our fork, and this is where all of our work in this chapter should be pushed. So let's go back here and we need to create a branch. So we're just gonna make sure that there is no changes. So I can go git pull origin main, cool, and everything is good here. And we wanna switch and create a new branch. So git switch -c, and we wanna call this branch feature remove command K. Cool. So we can see that we are in a new branch here. Now we preloaded this in here. Now we are using cursor to do this, so in the top right hand corner we can say I want you to remove the command K shortcut in the command window or in the header, but hopefully cursor should get this anyway. So cursor's gone ahead and done that. I'm going to go and check localhost, and we can see that it has made the changes effectively. So if I just go git status, I can see that 2 files were changed, and I'm happy with those changes. So I can then add these, git add dot, and of course, if we run git status again, we'll see that 2 have been staged. That's exactly what we want. And now we want to commit this, so I can go git commit -n, and we want to add a feature remove command K shortcut, and we can go ahead and hit enter. You'll see 2 files changed, 1 insertion, 21 deletions. Now we need to push this, and we're going to be git pushing -u to origin, and then the name of our branch. So feature remove command K. So this is the exact same as the previous steps that we did when we're working on the Nextwork marketing website. So I'm going to go ahead and click this and open up GitHub. Now, I mean, we could create a pull request like we normally would, but you can actually see I'm in the It's Nextwork repository. I'm not in Minimus 7, which is where I want to be. So what I'm going to do is actually just go out of here. I'm going to go to Minimus Next Sound, which is exactly where I want to be. And you can see here in Minimus Next Sound, it's going to open up a pull request, and it's going to take us back to the exact same place. Now, GitHub is going to pre-fill some of this stuff, and you can see the base repository here is Nextwork and then Next Sound. That's not what we want. We want our base repository to be our own. So basically what this is saying is take my branch from my fork and try to merge it straight into the original Nextsound repo. Remember, we don't want to make any changes to that. So this is how we can accidentally send PRs to this place. So what we want here is to change our base repository here to Minimus Nextsound. Now here you can check the differences here, so we can do exactly what we did before. I'm going to write a description here and just say we've removed the Command K shortcut from the search menu in the header section of our app. And we can actually go ahead and, like before, I'm going to assign myself this time as a reviewer, and I'm going to create a pull request. Like before, we could go ahead and add comments in to the files. But in this case, I'm actually just happy with what we've changed. And I'm going to go ahead and merge this pull request. Oh my gosh, I almost forgot the GIF. So let's put in the GIF. All right, let's go. Let's go. Confirm and merge. So here you can see things are now merged in, which is exactly what we want. And as normal, we can actually go git switch main, and then we want to git pull, and we can see the changes that have been made. Remember, if we wanted to make more changes when that PR is open, so when it's created, but it's not merged in, we can make more changes if we wanted to. Nothing is actually in production until it is merged. And once you understand that, PRs stop feeling kind of like magic, and these forks also start to feel less random. Keep in mind, if you're working in a team, you're not going to usually fork something, but we're just doing this for our day one because you need to learn, intern. All right, so you now know how to use branches and pull requests, but something that freaks a lot of people out is merging when you get conflict errors. Explain what a conflict is and how you think about it. Yeah, so a merge conflict can happen even if you're working by yourself. So let's say we start and we're looking at the header file again. Now we could make a change on our branch here. Let's say we change the title from Next Sound to Next Music. But on the GitHub UI, we also changed the main branch from Next Sound to Next Playlist. Now, if the changes are on different files or different lines, Git just merges them automatically. It only complains when it cannot decide which version of the same line should win. So a merge conflict is basically Git saying, I have 2 valid versions of a chunk file, and you need to essentially only choose one. So you may get an error like this. In order to fix this, it's always the same pattern. So you got to open the file up and decide which of the final lines should stay. So maybe you choose the local one, or maybe you choose the UI, or maybe it's a mix. Then you replace the whole conflict block with the final version only. So you got to delete the rest. Save the file, git add, git commit, and then you can merge. And if you've already started merging something and you're not committed yet, you can also go git merge abort, and this backs you out of putting it the working folder back into the state before the merge. You do not need to delete the repo, but I have definitely done this before. In most cases, it's exactly like this. All right, so you survived merge conflicts, but now we need to move on to something important. When you make a mess, how do you clean it up? What are the commands, the places where you need to look? This is an important one because essentially every oh no moment in GitHub is going to usually land in one of these 3 places: your working folder, your staging area, or your commit history. And there's different tools for each level. So if I'm trying to fix the working folder, I use git restore and then the file. If I'm trying to fix the stage level, I use git restore -- stage and then the file. And then if I'm trying to fix git history, I use git revert and the commit. Rule number 1 is obviously always use git status first so you can see where you are and then decide. Let's say you went wild in a file and you hate it. No commits yet. How do you go back? All right, so let's say I open this README and I just go ahead. I'm in a weird mood. I just delete half of it, right? And then when I run git status, you're gonna see that obviously we modified our README files. So Git can see that our README has changed in the working folder, but I haven't staged anything yet. But if I decide, man, that was a bad idea, I shouldn't have done that, I can actually just go ahead and type in git restore and then the file name. So in this case, it's readme.md. And now you see that it automatically updated there. I can then go ahead and click and type in git status, and you're gonna find that there is no changes. All right, that's not bad, but now show me how you unstage something without throwing your work away. Now let's say I've actually made some changes in the README, and I also go to the button in the TSX, and I'm just gonna make some changes here as well. Now I can just go run git status, and we're gonna see that 2 changes are made as we know, but we haven't staged anything. Now I could do the lazy thing and just go git add dot. So now if I go git status, we'll see that the README and the button TSX have actually been staged. Now if I commit now, firstly this button TSX is showing an error because I just deleted some of the imports. So I don't want to do that. I just want to commit the README at this stage. So what I could do is actually just go git restore -- staged and then the name of the file. So in this case it is src, and then we know that we can go / components / UI / button.tsx. So now if I go git status again, you can see that my README has been staged, but my components button TSX is not. So git restore stage, and then the file basically means take this file out of the next commit, but keep my changes in the working folder. So in this case, I actually want to restore those changes as well. I mean, that is good because that mistake alone creates half the junk history that I see all the time. Now, what if you had already made a commit? Now, if a commit is still local, so I haven't pushed it yet, I can safely fix it. So let's say I did something like git commit -m docs stuff. I mean, that's a bad message. Immediately, I realized that stuff is useless as a message. And if this is my latest commit and I haven't pushed it, I can amend this. So I can go git commit -- amend -m docs improve readme getting started section. So that new message is just improved there right now. So that keeps the same changes but rewrites the message for the latest commit history. If I also forgot to add a small readme tweak at the bottom, let's say like nice, I could then go git add readme.md and then git commit -- amend. That takes the existing commit and adds the newly staged changes from readme, and it closes it again as a single corrected commit. So as a simple rule of thumb, I only amend commits that I haven't pushed, because if I have pushed them, then other people might be using that, and that's going to create some conflicts. All right, you've done well so far today, but now I want you to go through the entire workflow. I don't know, maybe something small, something little, but go ahead. You got this. All right, let's do this. So first we're gonna start clean on main. Then we're gonna create a feature branch. From there, we're gonna edit code and test on local, commit our changes, push that branch to GitHub, open and merge a pull request, and then pull the latest main back to our laptop. What's the path that you need to take to do this? First thing I'm gonna do is just go git status. And this is exactly what we want. We're all good there. So now what I can do here is run git pull. So now I can just pull the latest changes and we're already up to date. That's great. At this point, our local main matches our remote main. So I'm safe to branch. So now I can create a new branch, feature switch -c, and I'm gonna call this feature like button. So now I can just double check which branch I'm in. And I can see right there, I'm in my feature like button branch. Now what I want to add is actually just a like button on each of these cards. So I'm going to take a screenshot here of the cards. I'm going to go back to cursor, and here I'm going to paste it in. I'm going to say, I want you to add a like button to each of these cards down below. The like button should be like a heart shape. And cursor's just gonna go ahead and do its thing. Cool, so cursor's all done, and I can see this like button works exactly how I want it to. Perfect. So now, as before, we can check what changes have been made. So it's just the track card. I'm happy with the changes that have been made. I can add them. Now, obviously I need to commit these changes. So -m, and this is going to be called feature, and it's going to be added in a like button. And we're going to commit these changes. From here, if I go git log oneline -3, we should see that my latest change has been made here.
Good, now get it off your laptop and push to Git.
Nice, so I have to share this branch now. So I need to git push -u origin feature like button. And this is creating a feature like button on our remote. So we set the upstream so that next time we can just run git push. Now for me, I've got to navigate into a different branch here. I can go to pull requests, create a new pull request. In here, my base repository is still Nick Sound. I want to change that. And I also want to change my main here to feature like button like we did before. And I'm going to create that pull request. So with the title here, I'm going to change this to feature, and I'm going to say create a like button. I'm going to, for the description, say, I created a like button on each of the card tiles so people can like their favorite song. And in this case, my boss has been watching over my back this entire time. So I'm going to create the pull request. If he wants to, he can go ahead and change, check all of the files that have been changed. But there's honestly not too many here. So we can go back to here. I'm then going to go ahead and merge my pull request. Confirm merge, and we are almost there, but my local branch still exists until I delete it myself. So what I'm going to do here is just switch to main, and then I am going to pull in the latest changes. So there we go. I've pulled in the latest changes. So now on localhost, I can see all the changes here, which is fantastic, exactly what I want. And then I'm going to go ahead and delete this branch as well. So git branch -d. The branch was feature like button, and we're gonna go ahead and delete it. And we are done, my friend. How good. This is day one complete.
What a day one. I am excited to have you on board. I'm glad that you know the basics of Git and GitHub now. It's been a long first day, but you've put in the effort, you've put in the time, and now you know 80% more than most of these engineers.
For the people watching this video, there was a lot of effort that went into this video. It's the first time I've ever tried doing something this long and this in-depth. So let us know what you think about it in the comments, and I hope this was very helpful. As always, you can go to learn.nextwork.org to get access to a bunch of hands-on projects. It is the best way to learn, and we will see you in the next one. Like and subscribe, do all that cool stuff. Peace out.